All right, guys, here we go. Differential equations review 3.0. I hope that everyone is happy. I hope that you guys are safe, and I hope that you guys are continuing the good fight. So let's see if we can continue to make an honest attempt, guys. We will have a quiz on this at the end of the week, or probably upload it as soon as I'm done with this. We will have a circuit, and then hopefully maybe we can see if we can have a mock exam. So yeah, so we have a busy week, and let's continue this good fight. All right. Excuse me, guys. What is the particular solution to the differential equation dy dx equals 2 sine x over e to the 3y minus 3 with the initial condition y of pi equals 1? All right, so the way to do these, and the way to do, not all of them, but most of them, we're going to separate this differential equation, guys, because they want a particular solution. So they want like y equals something. So I'm going to get the y's with the y's and the x's with the x's. So here we go. E to the 3y minus 3. And how did I get that there? I just multiplied by the denominator. dy equals 2 sine x dx. So perfect. I got the y's with the y's, the x's with the x's. Never go back to an x because they never change. Or no, just don't go back to an x, guys. That's not good. It's not good for your health. All right, continuing. So now what I'm going to do is I'm going to integrate. So that's how you get rid of the dy and the dx. So I'm going to integrate and integrate. So when you do that, the antiderivative of e to the 3y minus 3 is itself e to the 3y minus 3. Now, if I were to be taking a derivative of this with respect to y, I would have a 3 in the front. There is no 3 in the front, so either divide by 3 or put a 1/3 in the front. You guys know me, I prefer the fraction there. Equals, and then the antiderivative of 2 sine x, and yes, you could have put a plus c, but we're going to put the plus c with the x here because it's just easier. The antiderivative of 2 sine x is going to be a negative 2 cosine x plus c. Now, in case you're wondering, like, wow, how did you get that negative so quick? You can just put 2 cosine x and then ask yourself, the derivative of 2 cosine x is negative 2 sine x. And you don't have a negative there, so obviously there has to be a negative in your antiderivative. So that's how you do it, guys. So this feels like a good time. I guess we could continue times 3 everything and then ln. But I don't want to mess with the ln right now, guys. I know that y of pi is equal to 1 as a condition that they gave me. So what that means is that I have an x coordinate of pi and a y value of 1. So I'm going to insert this expression in for these two, and I'm going to see what I get. So I'm going to write 1/3 e, and if I plug in a 1, 3 times 1 minus 3 equals negative 2 cosine pi plus c. So you need a little bit of pre-cal, but it's not even that much, guys. It's just very little stuff. So 1/3 e to the 3 minus 3 is e to the 0 equals negative 2 cosine, and cosine of pi, well, I guess I already wrote cosine, so I'll leave it there. Cosine of pi is negative 1. So e to the 0 is 1, guys. So 1/3 times 1 is 1/3 equals, and then a negative times a negative is a positive, so 2 plus c. So that means that c must equal 1/3 minus 2. Now, yes, I'm going to go ahead and simplify this. A lot of you guys probably don't need to do what I'm about to do. You're saying, Travis, you're making it complicated. It's just negative 5/3. But I always have to do common denominators, so I always multiply that by 3, so 6 over 3. There's my 2, and then 1 minus 6 is negative 5. And I know some of you can probably do that in your head, but I went ahead and just wrote that out. So now that I know that c is negative 5/3, I'm coming back to this equation right here, guys. And so here we go. Yeah, I got plenty of space. So I'm going to write 1/3 e to the 3y minus 3 equals negative 2 cosine x minus 5 over 3. So what I want to do now is I want to solve for y, but I can't solve for y with this 1/3 there. So multiply everything by 3. Multi everything by 3. So when I do that, times 3 times 3 times 3, you're going to have e to the 3y minus 3 equals negative 6 cosine x minus 5, because 5/3 times 3 is just 5, guys. So now that we have that, now I want to bring down this exponent, the 3y minus 3. So to do that, you have to do an ln. Whatever you do to one side, you got to do to the other. So there you go. So now I'm going to have, and remember, ln of e is just 1. So I'm going to have 3y minus 3. And if you want to write the ln here, you can, ln of e, but make sure to put the 3y minus 3 in parentheses, equals ln negative 6 cosine x minus 5. And then I'm going to move the 3 to the other side. So 3y equals ln of negative 6 cosine x minus 5 plus 3. And I'm going to divide everything by 3. So when I do that, I get y equals, and I'm going to put the 1/3 in the front, guys. You can leave it as ln of all that divided by 3, but I'm not. I'm going to do it 1/3 ln of negative 6 cosine x minus 5 plus 1. And there it is. There's my initial equation, guys, with that condition. So yeah, we're done. And we're good. So now, and of course, if you plug in a pi in there, just to make sure that you have a positive argument, cosine of pi is negative 1. Negative times a negative is a positive. So 6 minus 5 is 1. So yeah, and then ln of 1 is 0. So you notice that when I plug in pi, you do get 1/3 times 0, which is 0, plus 1, which is 1. So you get your y value of 1. So it works. Check mark. Yay. I hope you guys like that. All right, let's go to the next one, guys. Oh, that's a lot of space there. I should have... Okay, anyways. All right, this problem is very famous. In 2017, this problem was blowing up on Twitter. So you can probably find it if you do like a Twitter search, potato calculus problem or whatever. So yeah, it's very famous. Some of the memes are really funny, guys. You should go check it out if you have some downtime. All right, so let's get right to it and let's see if we understand everything. At time t equals 0, a boiled potato is taken from a pot on the stove and left to cool in a kitchen. Okay, that sounds like something normal to do. The internal temperature of the potato is 91 degrees Celsius at time 0, and the internal temperature of the potato is greater than 27 degrees Celsius. Okay, for all times t greater than 0. So that 27 degrees is probably room temperature. I'm not going to make assumptions. I don't know, guys. But we know that the hottest it gets is 91. And the coolest it gets is 27. And it's always greater than 27 degrees. Because it says right here. It's always greater. So this is the coolest it's going to be. The internal temperature of the potato at time t minutes can be modeled by the function h that satisfies the differential equation dht equals negative 1/4 h minus 27. Where h of t is measured in degrees Celsius, and the initial temperature is 91. Yeah, they told us that already right here. So h of 0 is 91 is not a surprise, but they're being nice and they're giving us that information. Okay, so far I don't see anything crazy. Everything looks pretty good. Everything checks out. This is no calculator, guys. Question 4. All right, so let's see. Write an equation for the line tangent to the graph of h at 0. Use this equation to approximate the internal temperature of the potato at time t equals 3. All right, so let's do the tangent line first. We need 2 things for a tangent line. What are those 2 things? Yeah, you're right. A point and a slope. So we have our point at 0 because here it is. Our point is 0, 91. So there's my point. The h is like a y value and the x is a 0 value there. So, or your t value. So now I need a slope. And you're going to get the slope from right here, dht, guys. So let's find that slope. So dht, when t is 0, now look, t is 0, not h, is negative 1/4. And I guess you could have also put in parentheses 0, 91 if that helps. This is h. So you're not going to put in a t, you're going to put in your h. Your h at 0 is 91. 91 minus 27. And I guess you could leave it like that, but I want to figure out if that's a number. And I think we can do this without a calculator, guys, because it says no calculator, right? So let's see. 91 minus 30. 91, 81, 71, 61, and then add 3 more, 64. Yeah, and 4 does go into 64. Let's see. 4, 8, 16, 16, 16, 32, 60. Yeah. So it's going to be negative 16. 16 times 4 is 64. 16, 32, and then another 32, 64. So there it is. There's my slope. So here's my tangent line. I'm going to write y minus 91 equals negative 16 parenthesis x minus 0. And I guess technically this should be a t, and technically that should be an h, but that's fine. No big deal, guys. You'll get the full credit right here. So my tangent line approximation is y equals negative 16x plus 91. So this is like h of t, your h of t approximation. And it says to use this equation to approximate your temperature, your temperature at t equals 3. So h of 3 is approximately negative 16 times 3 plus 91. And you could leave it like this and you're done. But if you feel compelled to go and keep on going, then you can. The only thing that I got to tell you guys is make sure that you do not make a mistake. So here we go. I'm going to keep going. Negative 16 times 3. Well, I guess I didn't have to write that statement again. So yeah, let me just erase that and write what 16 times 3 is. 1632, 48. So negative 48 plus 91. And then I used to just make that like a 50, in my opinion. So I'm going to go ahead and do, let's see, 50, 60, 70, 80, 90. So that's 40. And then another 48, 49, 50, 91. So 48. What did I say? 50, 60, 70, 80, 90, 91. So that's 41. And then I add 2. So 42, 43. Approximately 43 degrees Celsius. And there it is. Use this equation to a temperature, and so there's my approximate temperature. All right. Hopefully I didn't confuse anyone there. You could leave it right here alone, and that would still be correct, guys. So now it says, use the second derivative to determine whether your answer in part A is an underestimate or an overestimate of the internal temperature of the potato at time t equals 3. Okay. What they're wanting us to do, so let me tell you the idea behind here. The second derivative tells you concavity. So think about it. If you are concave up, so here it is concave up, and you draw a tangent line, your approximation is always going to be an underestimate because your curve lies above your tangent line. If you're concave down and you have a tangent line, your approximation is going to be an over approximate because the curve lies below your tangent line. So hopefully that makes sense to you guys of why we're using the second derivative to determine whether it's an under or over. So we're going to let the concavity tell us what that's going to happen, guys. So here we go. I know what my first derivative is. Okay, let me write it. dH dt is equal to a negative 1/4 h minus 27. Okay, they're being kind of nice to us. This is a linear deal. If you want to distribute the 1/4, you can, but I'm going to leave it alone. So here we go. The second derivative is, so leave this negative 1/4 alone, and then this would have been, the derivative of h minus 27 is just dh dt. And don't leave it like that, guys. Rewrite it. So negative 1/4 times another negative 1/4 h minus 27. So we have 1 over 16 h minus 27. All right, so now h. Notice way up here in the stem of the problem, it says the internal temperature of the potato is always bigger than 27. So h is always larger than 27. Hence, this expression will always be positive. So I'm going to write, since the second derivative is positive, comma. So what does that mean if you're positive? Concave up. So the tangent line is going to lie below the curve. Our tangent line approximation lies below the curve. We only have one curve here. The curve, comma, hence, comma, under approximation. There you go. Like below the curve of h of t if you want to be specific, which we probably should. And there it is, guys. Perfect. I think I love it. I think I'm in love with this question. And I don't see any flaws on it yet. Let's see, positive, concave up. My tangent line's below the curve. Excuse me. So we're good. All right. And then I continued this for easy reading, guys, if we needed it for letter C. Let's see if we need it. For t less than 10, Oh, did I already answer all the questions on this one? Yeah, I did. Oh, you know what? Hence, under approximation, at, and let's be specific, at t equals 3. Okay, there we go. All right, let's see what letter C says. For t less than 10, an alternate model for the internal temperature of the potato at time t minutes is a function g that satisfies the differential equation dggt equals negative g minus 27 2/3, where g of t is measured in degrees Celsius and g of 0 is 91. Okay, this is still internal, the initial. So they're giving me another equation, as long as it's less than 10 minutes, that it behaves like this. Where gt is measured in degrees Celsius, find an expression for g of t based on this model. What is the internal temperature of potato at t equals 3? Okay, what you have to do here, separate your variables. That's all you're going to do. So I'm going to rewrite this, dg dt, that's the g, not a 6. Negative, parentheses, g minus 27 to the 2/3. I'm going to leave the negative there, and I'm going to move the g minus 27 to the left. So dg, man, what's wrong? Why can't I do g's? I swear I went to elementary school. Dg over g minus 27 to the 2/3 equals a negative dt, because I multiplied by dt. So there we go, guys. If you want to rewrite it, you can. You can rewrite it like 1 over g minus 27 to the 2/3 equals a negative dt, and then put the dg here, and then you can write it as g minus 27 to the negative 2/3 dg equals negative dt. All right, I'm going to integrate. So I'm going to add and then divide. So negative 2/3 plus 1 is 1/3, and then divided by 1/3, so I'm going to have a 3 in the front. So I'm going to rewrite that over here. I'm going to write 3g minus 27 to the 1/3. Now let me make sure that I did everything correct. 1, so 1/3, and then divide by 1/3, which is like 3. Yep. Equals negative, and I'm integrating in respect to t, so that's going to be a negative t plus c. This feels like, yeah, I guess this feels like a good location. This feels like a good location to plug in 0 and 91 to solve for c. So the 0 is the time, and the 91 is your temperature or your g. So I'm going to write 391 minus 27 to the 1/3 equals negative 0 plus c. So let's see, 91, and what I like to do is pretend that's like 30. 91, 81, 71, 61, and then add 3, 61, 62, 64. So again, I'm 3, 64 to the 1/3 equals c. We know what this is right here. So what number times what number times what number will give you 64? Well, that's a 4. So that means the cube root of 64. 4 times 4 is 16, and then 16 times 4 is 64. 16, 32, 64. So 3 times 4 equals c. So that means that your c is 12. All right, I'm going back to this expression right here, and I'm going to come back. So I'm going to write 3g minus 27 to the 1/3 equals negative t plus 12. So what we're trying to do is solving for t, right? So I'm just going to move this to the left and move this to the right. So I'm going to write t equals, I'm going to write negative 3g minus 27 to the 1/3 plus 12. And I believe that's it. Oh, wait. Did they want me to solve for t based on this one of the internal? No. They do not want me to solve for t. They want me to solve for g. Silly. So let me erase this. None of this is scripted, guys, as you can see. I just do it, and if I make mistakes, I make mistakes. So I'm going to divide by 3. They want you to solve for g, guys. Divide by 3. So g minus 27 to the 1/3 equals, negative t over 3 plus 4. And then I'm going to raise this to the 3rd power. I'm going to raise this to the 3rd power. So g minus 27 equals, and then leave this t over 3 plus 4 raised to the 3rd power, and then just move to 27. So g of t equals negative t over 3 plus 4 to the third power plus 27. So then they want me to use that to see what it is at 3, guys. So I'm going to do that in blue because I'm already getting pretty full here. So I'm going to write g. Let me see. I think I can write it right here. Yeah, g of 3 equals. And then let's see. 3 divided by 3 is 1. And that's going to be a negative 1 there. Negative 1 plus 4 is 3. So 3 to the third plus 27. You can leave it like that. That's full credit. But, you know, we can do better. 3 times 3 is 9. 9 times 3 is 27. So g of 3 is 27 plus 27. And we can do that. 25, 25, 50, 6, 7, 54 degrees Celsius. So there it is. As long as you don't make mistakes, you're good. If you are not comfortable, you can leave it at the first one there. But it's 54 degrees. Hopefully that made sense to everyone, guys. I had fun doing this one. I hope you did too. And yeah, let's get back in the swing of things, guys, and let's make it happen, guys. All right, give it a thumbs up if you enjoyed it, or just give it a thumbs up because, you know, well, if you want to give it a thumbs up, give it a thumbs up. I prefer one, but that's fine. All right, guys, talk to you guys later. Bye.